Okay, this video will cover page 152 through 153 of the notes and is going to emphasize how we approach solving type 1 errors. First off, you need to write down the null and the alternative hypothesis every time you see a type 1 error problem. It'll help you understand what the question is about. Off to the side, these are just reminders. Alpha is the probability of committing type 1, beta the probability of type 2, and that's the formula for power. The next thing, you wrote the null, you wrote the alternative, define the parameter in context. All right, define the next thing, and really you need to do every single one of these steps when you're doing a type 1, when you're approaching one of these problems. Give us a definition of what a type 1 error is. And I would say a simplified definition. Remember the probability of rejecting a null given that the null is true, or rejecting a true null and accepting a false alternative. I would much prefer you go ahead and say this, the probability of rejecting a null given that the null is true. And then you need to explain it in context. All right, so in this case, the probability of rejecting the null, and so you're going to restate the null in favor of the alternative given the fact that the null is true, okay? Then the very next thing you have to do, so this gives it in context, is explain the consequences. So here, this is in context. Now the consequence. And you're going to have to tie that to the actual problem. Make it in simplified language, not statistical terms. Make this easy for someone to understand. All right, so methods. First off, type 1 error is measured by alpha. Methods for decreasing. One, we can just decrease the alpha level, the significance level. We can just change that ourselves arbitrarily because we get to choose that value. But if we do that, it's going to increase beta. We're more likely to accept a false null, all right, and power decreases. So the result of decreasing alpha, that happens. We can decrease power, more likely to accept a false null, less likely to reject a true null, all right? That will also get rid of our, all of these are methods of decreasing type 1. And 3, increase sample size. Decreases type 2 or increases power, costs money and time. Truthfully, increasing sample size does not really help with type 1 errors, so we're probably better off just scratching that out. That's why I have it highlighted. Definition of p-value is provided at the bottom, because sometimes it'll ask you to do, what's the p-value? Once again, state the null, state the alternative, define the parameter, and then give the definition, because that shows that you understand it, and then put it in context. By giving the definition, if your context isn't perfect, they'll probably give you credit, at least half credit, if not full credit. So always give the definition prior to putting it in context. But if you don't put it in context, you're going to receive no credit. So let's look at a problem. Now this problem, we're going to take it a little bit farther than it says. And this came from 2008, Form B, question number 4. So a researcher wants to conduct a study to test whether listening to soothing music for 20 minutes helps to reduce diastolic blood pressure in patients with high blood pressure compared to simply sitting in a quiet, noise-free room for 20 minutes. 100 patients with high blood pressure at a large medical clinic are available to participate in the study. Propose a design for the study to compare these two treatments. Now, the fact of the matter is you could have tested the person twice. Once in the quiet room, and then let the blood, and then after enough time goes by, maybe a few days, etc., test them again. I chose not to do that. I chose to do this as where we broke them into 2 separate groups and tested one group against another group. Now, this is from the very beginning of the year where we actually collected data. So this is a reminder. Write the names of the 100 volunteers on 100 slips of paper. Place the slips in a bin and mix thoroughly. Draw 50 names without replacement. The first 50 will be assigned to the listening to soothing music. Remaining will sit quietly in a noise-free environment. Prior to administering the diastolic blood pressure will be measured for each volunteer. After the 20-minute treatment has passed, the patients will be again measured their diastolic pressure compared to pre and post to determine which treatment. So we have the group mu1, the true population mean for diastolic blood pressure drop for those listening to music. We also have a mu2, true population mean for diastolic blood pressure drop for those sitting in a quiet room. This is known as a two-sample mean test, and we will be working with those next week, right? They're not difficult. They really aren't. But in which case, I have two parameters that I had to define. This is the example I chose. So mu1 is for those listening to music. mu2 is those sitting in a quiet room. All right. And they're hoping that whether listening to soothing music will end up in a greater drop. All right. So is the drop greater for listening when I listen to music than when I don't listen to music? So a bigger drop versus a smaller drop in diastolic blood pressure. Well, type 1 error is rejecting the false, is rejecting the null when it's true. So I rejected this, but it was true. All right, because that's what it asked me to do in part B or part C. Excuse me, the null part B, I should read that. I apologize, stumbling over my words. The null hypothesis for the study is that there is no difference in the mean reduction of diastolic blood pressure, so mu1 equals mu2 for the two treatments. And the alternative is that the mean reduction in diastolic blood pressure is greater for the music treatment. If the null hypothesis is rejected, the clinic will offer the music therapy as a free service to their patients with high blood pressure. Describe a type 1 error and the consequences in the context of the study. Well, first off, type 1 error, definition, mistakenly rejecting the null when in fact it's true. In this case, we mistakenly believe that listening to music would have a greater impact on lowering blood pressure than sitting quietly in a room when in fact it doesn't. As a consequence, the clinic will be providing and paying for a treatment for patients that wasn't any more effective than just sitting in a quiet room. So they're paying for the music, and they're also telling patients that something works when it doesn't. And that might even be the worst part. They're telling people that it works when it doesn't. So a p-value of 0.0017 is calculated, explaining the meaning of the p-value in context and explaining what type of error may have been committed. Well, first off, what is p-value? We give it the definition. P-value is the probability of getting a test statistics as extreme or more extreme given that the null is true. In this case, there is a 0.17% chance that we'd get a test statistic this extreme in favor of music having a greater reduction in diastolic blood pressure than sitting in a quiet room, when in fact the two treatments are equal in their effectiveness. All right. So that's the definition. All right. A p-value of 0.0017 is less than alpha equal to 0.05. Thus, we would have rejected the null. If we reject the null, the only type of error that we could have committed is a type 1 error. All right. So if I reject the null, the only type I could have committed is a type 1 error. So in this case, I would be saying what we said up here, that the music worked when in fact it didn't. So they spent money to set things up when they shouldn't have. All right, the next video will cover type 2 error.